So I wanted to just think about a little bit, a couple of these, sort of strange problems that we're maybe, wondering about. Oh, does this converge? Does this diverge? So for instance, one of the problems on the homework was e to the x over x squared from 0 to 1, and wondering, okay, does this area right here, does that converge or diverge? I wonder if I can write in x equals 1, so then you can kind of see it would be this area right here. So really, when you're approaching these, what you want to be thinking about is, well, is there a function that I know converges or diverges that this is related to? And one thing we know about is 1 over x squared. And so looking at it from 0 to 1, you can see that the green line, which is e to the x over x squared, is greater than 1 over x squared for that entire region. If I scroll up, I can see this green graph is definitely above the black graph. And from a previous video, we know that 1 over x squared, the integral from 0 to 1, in other words, this area right in here, diverges to infinity. So therefore, this one would have to diverge as well because it is bigger than 1 over x squared, and 1 over x squared diverges. Another question was about cosine squared divided by x squared from 1 to infinity. So if I graph that, let's see here, graph that, oops. Looks like this. So I'm not really sure whether this converges or not. It kind of bounces up and down a little bit like that. But what I do know is that this is similar to 1 over x squared. And if I look at the graph of cosine squared x over x squared and compare it to 1 over x squared, I can see that it touches every once in a while, and that's where cosine equals 1. But on the whole, this graph is less than or equal to 1 over x squared. That's because cosine squared is less than or equal to 1. So that means that if the integral from 1 to infinity of 1 over x squared converges, which it does, then the integral of cosine squared x over x squared converges as well, because it would have to be somewhat less. We might think about something like that might not be quite as obvious, like 1 over ln x. And so you might think, well, I don't know about 1 over ln x, but I do know something about 1 over x, and that's that 1 over x diverges from 1 to infinity. So if I were looking at the area under 1 over ln x, I know that it also diverges because it approaches the axis even more slowly than 1 over x. So 1 over ln x would also diverge. Now you might think about like, well, what about something like 1 over x to the 5th minus 5? Because I know that 1 over x to the 5th converges, but subtracting 5 actually makes it bigger. If I compare this to, say, 1 over x to the 5th, this is actually bigger than that. So that's not helpful. But remember, you could always compare it to something that is bigger than 1 over x to the 5th, but still converges, like 1 over x to the 4th, or maybe 1 over x cubed, or maybe even 1 over x squared. I know that 1 over x squared converges, and 1 over x to the 5th minus 5 is way smaller than 1 over x squared, so I would know that as I approach infinity, that also has to converge. So be creative with what you're comparing with. Sometimes it can be kind of obvious, and sometimes you just want to mess around and think, oh, well, can I find something, I think this converges, can I find something that it is smaller than that also converges? Or, oh, I think 1 over ln x diverges, can I find something that it's bigger than that diverges?